Please forgive the terrible quality of this video. I am not used to doing this stuff. I am not a YouTube creator, content creator. I'm just a teacher, and I have a question that does not make sense. And so I'm trying to ask the sciencey people on YouTube because I figure you guys have more experience with these sorts of things than me. And CyroPyro, probably you're the first person I'm going to send this to because I know you do a lot of work with lasers and you understand their mechanisms and how they work. But I wanted to show you something that I found that did not make sense to me and that I've been trying to research and have not found a conclusive answer for. So I'm trying to throw it to you and ask for some help, just for some guidance about what's happening. So let me explain the setup and kind of the whole, the problem that I'm seeing. Switching the camera around. This is my totally not thrown together on the floor of my classroom lab setup. I've got a laser that I inherited from someplace. I don't know where it is. It's a helium neon laser, pretty old. I guess maybe it'll be useful to show the power supply and everything else like that. And then there it is. And if you look, there's a red dot that it creates. And I have something else that I have in front of it. I've got a polarizing filter. So this is just something that happened, and I was kind of fiddling around with it. I wanted to show polarizing light and everything else. I had pulled the laser out just to show some students. What you can see next to it, that blue thing is a light sensor that I have hooked up to my computer through the Lab Pro. And I'll get to that data in just a second. But if you look, and this does take a long time now. Try not to get in the light. I probably did actually get a little bit in the way of it. Well, I guess I can show it up on the screen because right now it's actually reasonably bright. But for some reason, when you shine the laser through the polarizing filter, its intensity diminishes over time, and then it re-brightens, so it goes back up. So this is the data that I've been collecting for quite a bit of time now. You can kind of see the voltage potential right there. The light is still shining, so I'll try to catch it a little bit better. But that's the data I've collected. I'm going to try to look at it and analyze it a little bit better. You can see over time how it's brightened and dimmed kind of in a periodic fashion. It does look like, I'm a little intrigued because you can kind of see the edges of that graph are not exactly straight. There's sort of there's a bit of a curve to it on both sides, and I think it's probably related to the I don't know what it's exactly related to. I'm just trying to explain this. I don't have any explanation because all this is doing is putting it through a polarizing filter. And if you don't put it through a polarizing filter, its intensity remains the same, remains constant. So for some reason, this polarizing filter is interacting with the light in a way that then causes it to brighten and dim. And I honestly cannot explain this. I don't understand it. I'm befuddled. I'm trying to look up how lasers work, how the lasing of the helium neon material causes this. Is there a polarizing element to the whole process of lasing? And is there something? I don't think there's anything else rotating, because it does seem to be sort of working. I think it seems to be kind of working on a periodic basis that then is increasing in time. I might be running near the end of my data set, so hopefully I can get that data. I'll see if I can download it and show it to you. I really would love to show the actual intensity when it diminishes. I think it's starting to go down now, so maybe we can watch it for a second, maybe another few minutes. It's unfortunately the screen, or I'm really using a really old laptop and a really old Lab Pro. And so it's hard to, and I may have messed with the data just by coming over here. I left it alone, no one else is in my classroom, so it wouldn't interrupt the light sensor, because the light sensor is just a generic light sensor. It's not, But anyways, it's starting to diminish now. You can kind of see it. I hope I can just record this last piece. Anyways. Yeah, maybe we'll have to wait just a while, so hopefully this part of the video won't be too terribly boring. Anyways, the point is, I have a phenomenon I don't understand, and I'm trying to investigate it using my limited tools and my definitely limited understanding of lasers and why this whole process is happening. But I just didn't expect it. I didn't expect there to be a polarity to the laser that then was changing over time, because that's apparently what it is. If we have a polarizing filter, I think, is it diminishing now? It says it is on the screen, but I don't, because of the delay in my lab setup and how old this is. I don't know if I don't know how accurately updated that is. Well, I think you can see it if you're looking. So now this is, towards the later part of it, it certainly is a longer time span. It does seem to be diminishing in a way you can see it. There you go. Yep, it's fading, dimming. There you go. That's exactly what I was hoping to show. So I don't know what this is doing. I have absolutely no idea why it is doing this. I wish I could understand it, and I'm trying to understand it, but at this point I'm just completely bewildered. So any insight into what's happening, the physics behind it, is something I'm just, because I found it when I was just talking with students and I couldn't explain it. I've since tried to capture the data in a more coherent way. I was using a stopwatch for a while, which is really rough, especially when you have at the very beginning. And that is something else that I think is important. The laser box itself is getting warm to the touch. I don't think there's much change in the power supply that I could see, but definitely the box in and of itself. If you, I can take a measurement of the heat of the box. Which, assuming that it starts at room temperature, now it's at about 45 degrees Celsius, when the surrounding area is about 22, so substantially warmer than the surrounding air. I expect that has something to do with it, but yeah, why? Like, what am I looking at? Why is this happening? Do you have any insight that can help me explain this? How does the length of the laser itself change as it warms up, then that changes the polarity of the light that comes out of it? Or is there something else that's happening in the physics realm that I don't understand, because I don't have an advanced degree in any of the PChem? I mean, I took PChem years ago in college. I don't remember learning anything like this. So any insight that you have would be greatly appreciated. Thank you so much for helping me understand this, and have a great day.